Good afternoon, everyone. I'm Paul. I'm a solution architect, and I'm a cloud business manager for Trend Micro for AMEA region, and I'm here to talk about a couple things. One of them is what the financial services industry is doing in AWS, and how do you secure your DevOps environment. And like what Miles were saying a while ago, we're going to be looking at automation, and we'll be showing about automation stuff later. All right? So, before we start with this one, may I get a show of hands? Who's a developer here? Any developers? Ops guys? Cloud guys? Security guys? Using AWS? All right. So we got a bunch of people here. So there is going to be some demos, and we will be showing some new products from Trend Micro as well. All right. So I'm just going to talk about some of our customers who's using AWS, and one of them is a stock market financial regulator. So what they do is they analyze billions and billions of transactions every hour, and their main challenge is how do they detect fraud in those transactions. So if they're not using cloud, it's going to be a lot challenging for them because they have to, to process huge amounts of data. Another customer that we have is a major bank in Singapore. So they opened up an API to the financial, the fintech industry that gives obfuscated transaction data. So you can actually run your queries and you can build your products on top of that data. And there's a lot of fintech companies. And those fintech companies won't be able to scale up and innovate as fast if they're not using cloud. So companies like Matchmove, Red Dot Payments, or Bondlink. And Bondlink is downstairs. Okay, so when I talk to them, they have specific concerns. And some of the summary that I get from them is, the thing that CIOs or the DevOps people ask me is, how do they keep the customer data secure, first and foremost? Next one is, how do they secure a massive amount of instances or servers across on-premise and on AWS? And when you're building these cool APIs, it's all about securing your APIs. How do you make it secure? Because everything runs on apps, and if it runs on apps, you need good APIs. And of course, you cannot escape compliance and regulatory. Miles was talking about it a while ago. And we have automated security testing. So how do you automate security testing? So this is where DevOps and security comes in. Okay? So in the old days, the way people build things is, build teams is, there's a security perspective from a developer side, and then there's a security perspective from an operations side. So they have their own sets of controls in them. So developers, they have their code reviews, and they have their code analysis tools. So that's how they look at security. And the operations team, they look at network security, they look at instance security, and they look at compliance. So it's very clear-cut. Anything that's related to code, developers look at. Anything related to security, the operations people look at. But when you go to the cloud, it's all about moving fast and moving secure. So it's moving fast and secure. It's not one way or another. It's not fast, it's not secure, it's both. And Miles was talking about it a while ago. Security is job zero. But if you're a developer, your job is ship code, get your products out. And this is where we see the DevOps chain. So this is where people are going to talk about DevOps chain. And I showed you a chart a while ago with dev and operations people. And when you go to this chain, it changes. So there's a lot of steps in the DevOps chain, but the responsibility moves. So for example, the vulnerability in code analysis, it goes to the test. And the operations, the network security, instance security, and compliance go to the ops. But how do you put more controls to the entire loop, to the entire pipeline? So this is where people will ask, how do you put all this cool stuff that cloud gives you to enhance the security of your pipeline? So let's look at the left side. So when you're looking at DevOps and security, the challenge is moving security to the left. The old ways is put everything to the right, put everything in operation, put everything to the security guys. But how do you move security to the left? The questions that people ask, my customers ask me is, are we using the right tools in our pipeline? Number one. Number two, how do we integrate security in the CI/CD pipeline? Because there's a lot of steps, and how do we make sure that things or code or application before it hit production is actually secure? How do we know the integrity of our sources? Because, you know, a lot of us, when we develop code, we get a lot of inspiration from the internet, from Stack Overflow, from GitHub. And how do we know that some of them are actually safe? And the last thing is, how do we keep the traditional security controls in the left? So this is where, you know, all this AWS artifact comes in. How do we match it? So I'm just gonna go to some scenarios. I took AWS exams, and if you're aware of security exams, my scenarios, we're just trying to do it the same way as, you know, how they ask questions. So I have this scenario. Your team has decided to check the integrity of the images in your pipeline, and you are tasked to check if your containers have any malware or vulnerabilities. So this is all about Docker security. So just to do a level set with everybody, the way Docker works is a developer writes an image with their applications and their code. He pushes it to the registry, and that image is being pushed out to production. So that is the basic workflow. The way images are built is actually multi-layered. It's not just one layer. So the way it works is like this. So you have your operating system, which is Ubuntu. It's made by Ubuntu. And then you have your HTTP, who's made by the Apache Foundation. And then maybe your ops team decides to put a layer on top of it. For example, let's modify the config files of HTTP. Maybe put our SSL certs there. And then you give it to the developers. So the developers install their code to the last layer. And that last layer is the one that you push to production, to your registry. Now, you're gonna ask, how do you know if there's vulnerabilities on top? How do you know if the sources are clean? How do you know if there's no malware on the middle layers? So I'm just gonna do a quick demo on this. I love demos. So let me go to my machine. Okay, so I have here Trend Micro's about to be released product. It's called Deep Security Smart Check. And what it does is basically it looks at your Docker containers, and it looks at vulnerabilities and looks at malware inside. So let me show you. I have my sample application. And inside the sample application, it says it's scanning all my Docker images. And then it tells me the vulnerabilities inside. It tells me that my container has a malware, and it tells me that I did one scan in the past 24 hours. And it's gonna show you. I'm gonna show you the image that I just have in that system, right? So what it does is it actually checks every layer of the container, so of the image. So it checks every line in the Docker image, and it's gonna tell you which vulnerabilities it introduces. So let me go to here. So I installed Git, an old version of Apache, old version of PHP, old version of MySQL. And because they're quite old, it introduces a bunch of vulnerabilities. So as a security guy, as a developer, you'll know that your application needs to update. You need to update that. And towards the end, it also shows me if there is a malware inside. So I inserted a line here. Okay, I inserted the line here that says download an ICAR malware. So that ICAR is a sample malware, and it will tell me that in this line, I introduce a malware to the system. All right, so this entire product is built on Kubernetes, and it's API driven. So you can tell your Jenkins, you can tell your CI/CD pipeline to call on this as soon as the developer does a submission of the image. So let me just show you the slides again and what it contains. All right, so this is how it works. Developer, right? You commit the image to your repository. Jenkins builds it. After the image gets built, it gets sent to Deep Security Smart Check, and then either reject or sign it. You can send it to your registry, or you can let the user know in Slack that there's a vulnerable image. So yeah, that's how you secure your Docker container. Now, the next one is, let's go to the right. So we're talking about operations now. So what customers are looking for to the operations side. So one of the main questions is, like what Miles said, how do you quickly react when there is noise? If there's any incident, and what do you do with all the noise that you get? Because you have so many logs, you have so many information, and so many data comes in your streams. How do you make sense of it? You have so many activities, and how do you make sure that your configuration is still secure? And we have a scenario for that. So your security team implemented GuardDuty. How do you ensure that your instances are protected from those attacks? So just to give you a brief introduction on GuardDuty and how it works. So basically, GuardDuty gets information from your VPC flow logs. It gets information from your AWS CloudTrail, and it gets data from your DNS query. So if an instance makes a malicious DNS query, it will be picked up. And it will alert the user, and it can be automated. So you can trigger a Lambda function to when things happen. So I'm just going to show you how it works instead of showing you the chart. Okay. All right. So what I'm going to do here is I'm going to run Nmap. I already pre-entered all the details here. So if you don't know what Nmap means, that means it's a port scanning tool. So I will check all the open ports of my instances. I'm going to hit enter, and it's going to run it. It will take some time, so I'm going to, in like a cooking session, we will show you the cooked product already. So at the back, you're going to see that an instance, an unprotected port of the instance is being probed. So it will tell you that this is your instance ID, and it will tell you that this is the port, and it will tell you that this is the network interface, and it will tell you that the server is being probed. So what does it mean if your server is being probed? What are they actually trying to do? When your instance is being probed, it checks all the applications in all the ports. That means the next step is to look for vulnerabilities in your application. So what's the next step if they know the vulnerability? It's going to be exploited. So I have here a Lambda function that reacts to those calls. And I'm going to show you what it says. So in my Slack, so what it tells, it goes to my Slack. Oh, it's small. Okay, let me make it bigger. All right. In my Slack, it actually tells the user, it will actually tell you that based on a suspicious finding in GuardDuty, Deep Security is now scanning this instance for rule recommendations to ensure that security profile is accurate and up to date. So what does this mean? So what it does is it tells Deep Security to apply virtual patching to your instance, and it will tell Deep Security, let me log in. It will tell Deep Security either to install virtual patching or scan for malware or check your instance for any issues. So it doesn't just you don't just get intelligence from GuardDuty that you're being compromised. It will actually prevent your system from being compromised. So it's automated, proactive protection of your instances. So yeah, let's go to the slides again. So what happened there? So I initiated a port scan to that server, and then GuardDuty has detected it. And then I have a Lambda function that GuardDuty triggers. And that Lambda function initiates a scan for recommendation to Deep Security. Tell that server to add security controls. So in the old days, if you see your instance being probed, you're gonna apply the patch. You're gonna change the firewall rules so that your instance will not be compromised. Now, talking about patching. The next thing that we're going to talk about is patching. Who patches stuff here? Anybody patch servers here? All right. So, all right. So our next scenario. Your team is managing 200 instances in AWS, and then a zero-day strikes. What is a good way of protecting them? Now, as you all know, people here are patching stuff. It's not instant, because for some reason, patching time takes a while. So for example, zero-day has been announced now. There's a lag before you can apply the patch in UAT. And then there's another lag for you to test it, and then there's another lag for you to deploy it. The industry average is 176 days. And that's 176 days that most of the servers are vulnerable to attacks. So let me show you some, how does this, how do we patch quickly? So a while ago, we ran a port probe. So after a port probe, what will happen? So they detected that there's an exploitable port. So I'll give you an example, like, your instance is unpatched for WannaCry. So I have here Metasploit. So Metasploit is a hacker tool. So I already preloaded everything, and I already preloaded the vulnerability that I want to exploit, which is the eternal blue. So I'm just gonna type exploit. Right. So after I run the exploit, it blocks the traffic, and it says communication error, an error has occurred. And of course, when this happens, that means the traffic has been blocked. Now, how do you get instant notification on this? So let's go back to my Slack, and my Slack tells me that this instance has an intrusion prevention attack, and it has been baselined for available patches. And it will ask you, would you like to patch this instance? So how does that work? People will ask me, how does this patching work? So it's virtually patched, and it will ask the user if they want to real patch the server. So I'm gonna go back to my AWS. And I have here a Lambda function that actually, I wrote a Lambda function that actually tells AWS SSM to run a baseline. So how does a baseline look? So this is the command that it just ran. So one of the commands, I did it this morning, so I don't have to switch screens. So this is the command that happened a while ago. So the Lambda actually told SSM to run a baseline of patch. And what patch baseline means is check your server for available patches. And the result is like this. So this server will tell you that you have a lot of missing patches right here. And this is actionable. The question there is, do you want to patch it or you don't want to patch it? So this is where it's gonna come in, and depending on your operations team, do you want to patch a server or not? And I put a button in Slack, so it will call another Lambda function to actually patch a server and tell AWS to do a run command. So just in case you got lost there, I'll just show you again the slides. So what we did there was we run a Metasploit to the instance, and then Deep Security picks it up, and it will tell AWS Lambda to invoke a run command. So run command is AWS version of running commands on your instance. It will tell him to scan the server for patch. And you have your DevOps person saying yes or no, and you can patch it. So this is what I call end-to-end security. It doesn't just virtual patch it. It doesn't just tell you that we prevented you. It also tells you, hey, patch your server, please. So with this demos that I have, I hope that I was able to demonstrate that in AWS, it's really not hard. It's not hard to shift your security to the left. So when I say shift security to the left, you're putting security controls to the left of the DevOps chain, meaning earlier, before you send code to production. Smart Check allows you to do that when you're using a Docker environment. And again, automate incident response. If you want to know more about Smart Check or our automation, we have a booth downstairs. Most of our products, Deep Security is available in AWS Marketplace. We're an advanced technology partner. And yeah, with that, I would like to thank you. And I hope you can rate my session. So have a good afternoon, guys.